Okay, that's the single edge. Okay, now again, what are the difference between weighted graph and unweighted graph? Just now we learned about directed and undirected graph. Okay, we need to know how to compare and contrast the directed and undirected graph. So for now, we need to compare and contrast what is weighted graph and what is unweighted graph. Okay, now if you can remember in the previous lesson that I explained just now, there is no writing in on the beside the edge. Okay, for example, if you can see in the diagram example 8, there is something written at the edge. Okay, it can be distance, it can be time, it can be anything. Okay, so this is what is called weighted graph. Okay, weighted graph is a directed graph, or it can be undirected graph. Okay, but the edge is associated with a value or a weight. Okay, that is the difference. Okay, for weighted graph. But for unweighted graph, it's not associated with a value or a weight. So for what I have explained just now, there is no value. That means that is unweighted graph. Okay, unweighted graph for simple graph, graph with loops and multiple edges, directed and undirected graph, that is all unweighted graph. But for weighted graph, okay, there must be a value given. Okay, this is the weight for the network. Okay, example, let's look at example. The edge represent distance. Okay, for weighted graph, traveling time, current, cost. Okay, but in unweighted graph, the edge relates information like job hierarchy in an organization chart. If you can see organization chart, no weight. Okay, no weightage. Flow map, tree map, bubble map, no weightage. Okay, so the value here we call it weightage. Okay, that is why it is called weighted graph. Okay, now let's look at example 8. The diagram on the right shows one-way paths that Izarul can choose for his running practice. Vertex V1 is the starting position and vertex V5 is the ending position before he goes home. Determine A, the shortest distance from V1 to V5. B, the longest distance from V1 to V5. And C, the vertices that must be passed through if the distance of the one-way run is between 1.4 km and 2.1 km. Okay, so it's a one-way path. Okay, from V1 to V5. That is the problem. So the question is to find the shortest distance from V1 to V5. So you must try. Okay, you must try from V1 to V5. Okay, so if you can see V1 to V2, then V2 to V5. Okay, so the distance will be 600 plus 500, 1100 meters or 1.1 kilometer. But if we take the path from V1 to V3, then V3 to V4, then V4 to V5, it will be longer. Okay, more distance involved. Or maybe V1 to V3, V3 to V2 cannot, because the direction from V2 to V3, we must follow the direction. Okay, so this is weighted and directed graph. Okay, but we can also try V1 to V2, then V2 to V3, then V3 to V4, and then V4 to V5, but it will be longer. Okay, but the question is the shortest distance. Okay, the shortest distance means we will take the route from V1 to V2, then V2 to V5. We will get 1.1 kilometer. Okay, B, the longest distance Okay, the longest distance, like I said just now, from V1 to V2, then V2 to V3, V3 to V4, then only V4 to V5. So we will get 2.5 kilometers. Okay, so now you can do the self-practice 5.1b, okay, in your textbook, page 138. Do it again in your exercise book and check your answers. Okay, now we proceed with the third learning standard. How do you identify and draw subgraphs and trees? Okay, just to recall what we have learned just now, we have learned about simple graph with multiple edges and loops. We have directed graph, undirected graph, weighted graph, unweighted graph. Okay, you must see the difference between all the graphs. Okay, now next we are going to identify what is subgraphs and trees. Okay, so a vertex in graph G is a subgraph of graph G, and edge in graph G along with the vertices it connects is a subgraph of G. Each graph is a subgraph of itself. Okay, now let's look at example 9 to make you understand more. Determine whether diagram 1, diagram 2, diagram 3 and diagram 4 are the subgraph of graph G. Okay, diagram 1. Okay, we are given the graph G here. Okay, this is graph G. So diagram 1, is it a subgraph of the graph G? Yes, because the vertex pair for the edge E5 is the same. Okay, if you can see, PS is E5. Okay, and here is also E5. Okay, we take out some of the edges. Okay, like in this case, PS, one edge only. Now diagram 2. Diagram 2, no, because the position of loop E2 is not on vertex Q. Okay, if you look at diagram 2, the difference from the graph G is the loop should be on vertex Q. Okay, but here on vertex P, so it's not a subgraph. Okay, how about diagram 3? No, because the edge connecting vertex P and vertex S is not E3. Okay, so PS should be E5, but this is E3. So it's not the subgraph of G. And diagram 4, no, because the loop and the edge connecting vertex Q and vertex R are wrong. Okay, so if you look at Q, okay, the loop here should be E2, not E3. Okay, and then QRH here must be E3, not E2. So for diagram 4, it is not the subgraph of G. Okay, because of the edges are not the same as G. Okay, so subgraph is more like a subset that you learn in set. Okay, now how about tree? This now subgraph, and this time is tree. A tree of a graph is a subgraph of the graph with the following properties. A simple graph without loops and multiple edges. Okay, it must be a simple graph for a tree. All the vertices are connected, and each pair of vertices is connected by only one edge. No multiple edge. Okay, only one edge. That is why it must be a simple graph. And the number of edges equals to number of vertices minus 1. That means if we have 5 vertices, the number of edges must be 4. Okay, if we have 7 vertices, that means the number of edges must be 6 minus 1. Okay, 6 because we take 7 minus 1 and minus 1. Okay, this is number of vertices minus 1. Now look at diagram 1. Diagram 1 is a tree because all the vertices are connected. Okay, if you can see here, all the vertices are connected. Then every pair of vertices is connected by an edge only. Okay, ED one edge, CD one edge, CB one edge, AB one edge. There are no loops or multiple edges, and 5 vertices and only 4 edges. You see the number of edges, it must be 5 minus 1 equals to 4. Okay, now how about diagram 2? Diagram 2 is not a tree because vertex B and vertex E can be connected in 2 ways. Okay, what does it mean in 2 ways? Okay, because we can connect B and E by single edge BE, or we can use another way from BC go to D and then we can go to E. Okay, so there is more than one way to be connected B and E. Okay, and also we have 5 vertices and 5 edges. Okay, that means this is not a tree. So remember, a tree is a simple graph. Okay, and the number of edges is the number of vertices minus by 1, and there is only one way from one point to another point, or from one vertex to another vertex. So now let's look at example 10. Determine whether each of the following graph is a tree. Justify your answer. Okay, so now let's look at diagram A. Okay, so diagram A is not a tree. Okay, why is not a tree? Remember, a tree, it must be a simple graph, and the number of edges must be minus 1 from the number of vertices. Okay, so not a tree because we have 6 vertices but 7 edges, and each pair of vertices can be connected in various ways. Okay, for B, for B it's a tree because we have 6 vertices and 5 edges. Okay, 1 less than the number of vertices. Then each pair of vertices is connected by 1 edge. If you can see, let's say from P to T, there is only one way from P to T. Okay, now C, a tree. Okay, why? Because it has 6 vertices and then 5 edges, and so that each pair of vertices is connected by 1 edge. Okay, how about D? D is not a tree. If you count the vertices and edges, okay, so it's not a tree. Furthermore, vertex R and vertex T are not connected to the other vertices. Okay, if you can see, yeah, vertex R and T. Okay, now example 11. Draw a tree for the following information given. So we are given 6 vertices, so you must draw a tree. Remember, what is the condition for a tree? It must be a simple graph. Okay, and the number of vertices is 1 more than the number of edges. Okay, and then every 2 vertices is connected by only 1 edge. Okay, so 6 vertices, the edges is 5. Therefore, the diagram is like this. Okay, if you can see, we have 6 vertices and 5 edges, and 2 vertices is connected by only 1 edge. Okay, now how about B? We have 8 vertices. That means we must have 7 edges. Okay, so you can draw any way you want, but as long as the pair of vertices, okay, is connected only by 1 edge. Okay, how about 4 edges? 4 edges, that means the vertices, the number of vertices must be more 1. Okay, from the number of edges. Therefore, okay, you can see the pair of vertices is connected by only 1 edge. Every pair, if you can see 1, 2, 3, 4 pair. Okay, 9 edges, that means we plus 1 for the vertices, must be 10 vertices. Okay, and every pair is connected by one edge only. Okay, so you can draw as you want, as long as it fulfill the 9 edges and 10 vertices, and a pair of vertices is connected by one edge, and it must be a simple graph. Okay, that is the condition. So now let's try with example 12. Draw two trees based on the graphs given below. Okay, so for question A, we are given 5 vertices. Okay, so to draw a tree, we just follow the position of the vertices from the diagram. Okay, and then since that we have 5 vertices, that means we need only 4 edges to make a tree. Okay, so I'll take this one, 1, 2, so we have 3 and 4. Okay, so 1, 2, 3, 4, 4 edges and 5 vertices. This is one answer for a tree. The second answer, let's draw the same vertices. Okay, and this time I will take 1, 2, 3, 4. Okay, so 1, 2, 3, 4. Okay, so you can check 5 vertices, 4 edges, and from one point to another point there is only one way. For example, from this point to this point, so we have only one way to reach the point. Okay, how about B? Okay, for B, the vertices 6. Okay, so we need 5 edges. Okay, so which 5 edges will we take? 1, 2, okay, 2, and then 3, 4, 5. Okay, so we can check 5 vertices and 5 edges with 6 vertices. Okay, but you can also check from this point to this point, is it another way to reach? Okay, there is only one way. Okay, from here to here. Okay, cannot use another way. Okay, so you can check your answer. So this one is okay, a 3, and the second 3, okay, the same position. Okay, let's take 1, 2, 3, 4, and 5. Okay, so 6 vertices, 5 edges, and again let's check. Let's say from this vertex to this vertex there is only one way, from this vertex to this vertex also one way. Okay, so all vertices can be reached at one way only. Okay, so these are the trees that we can get from the given diagram. You may get some other answer. Okay, it's okay as long as it follows the rule. Okay, now example 13. The following diagram shows an undirected weighted graph. Okay, this is undirected, no direction, and also weighted graph. There is weightage for each edge. Okay, so draw a tree with a minimum total weight. Okay, now we know for a tree it depends on the number of vertices. Okay, so our number of vertices is 1, 2, 3, 4, 5. Okay, so that means we have 5 vertices, therefore it should be 4 edges. Okay, but what we have here is about 7 edges, so we need to remove 3 edges. Okay, which one to remove? Okay, since that every edge has its own weightage, okay, so we will remove first the highest, or the larger number. Okay, the bigger number. So because to keep it minimum total weight. Okay, so we take out 20, 25, 19. Okay, let's draw the 3Q, and then we have T, 10, and then R. Okay, so from T to R is 12. Okay, and then from R to S. Okay, S, this is 17. So 1, 2, 3, 4, another one, T to S. Okay, 14. And another vertex here, P. Okay, this is the first step. Okay, because we want the minimum total weight, that means we take out the bigger number, because we want to keep all the small number. Okay, so from here we know that the three bigger numbers are 20, 25 and 19. This is the first step, but it's not necessary is correct. Okay, so we must check every step that we do. So if you can see from here, P is not connected to any point, any vertex. Okay, that means we have to take back the edges that we removed just now. Okay, and maybe we can take out another edge. Okay, so let's put back 19. Okay, because that is the smallest between the three. We want to keep the total weight minimum. Okay, since that we put in the 19, we must take out one edge. Okay, so which one? If you can see RST, okay, RST, we can take out one edge. Okay, so between 12, 14 and 17, which one is the biggest number? So 17. So we take out 17. Okay, so 17. Let's try an error. Okay. Okay, now let's check. Is it a 3? Okay, we have 5 vertices. Okay, the same as the question. So 4 edges. Okay, and then it's connected to all vertices, and okay, from one vertex to another vertex, there is only one way. So this is the final answer. Okay, this is the minimum total weight. So minimum total weight equals to 10 plus 12 plus 14 plus 19. So we will get 55. Okay, is that clear? Okay, next. Okay, try to do self-practice 5.1c in textbook page 142 in your exercise book. Now, the fourth learning standard, to represent information in the form of network. So just to recall again, what we have learned before this is what is simple graph, what is graph with loop and multiple edges, then directed and undirected graph, weighted and unweighted graph. Okay, and then how we draw subgraph and also a tree. That is all about the basic about network. Now, how would you represent the information in the form of network? Okay, the information that we have in the real life situation, how do we transform it into network? Let's look at one example of transportation network. In the previous slide, the first slide just now, I mentioned about the transportation network and also the social network. So let's see one example is transportation network and one example in social network. Now, example 14. Mr. Woon and his family plan to visit historical places in Malacca. The map shows 3 alternative routes with the distances and estimated times needed to travel from Tangkak to Formosa, Malacca. Assume P is a 46.3 kilometers route. Q is a 50.2 kilometer route and R is a 53.3 kilometer route. In your opinion, why does route P take the longest time compared to the other routes, even though route P is the shortest route? Okay, so based on the maps, I think you guys have shown these maps, okay, because when you want to go to any place that you don't know, your parents don't know, they will use these maps or Waze, okay. So the maps, okay, it shows that town P only 46.3, but the hours taken is 1 hour and 80 minutes, okay. But for Q and R, okay, almost the same, 1 hour and 2 minutes, and also the distance also almost the same, like 50 and 53. So why is route P is took longer time than the other routes? Okay, because it takes the longest time because the route passes through crowded town areas and there are more road users compared to the other two routes. Okay, that is why, you know, even though the distance is shorter than Q and R, but it takes times because of the because of the route is going through the town and cities. It's a very busy route. Okay, that is why the time taken is longer than the two routes. Now, let's look at another example of doing information with networks. Okay, social networks. Example 15. The table below shows the data of 6 pupils and the games that they like. Represent the information in the form of a network. So these are the name of the pupil and the game that they like. Okay, so now let the vertices represent types of games and the ages represent the pupils' names. Okay, so we can connect every games, okay, with those who like the games. Okay, so this is the games and the ages. Okay, let's say chess and badminton. Who likes badminton and chess? Okay, chess, Edmund, Rajan and Aina. Okay, Edmund, Rajan and Aina. Also yes, Edmund, Rajan and Aina. For badminton we have Edmund also, and then we have Maria, okay, and so on. Okay, this is an example of the use of network in the social network. Okay, so now you must try yourself in for the self-practice self-learning in your textbook page 145, and please check your answer. Every time you do the exercise, please check your answer. Any problem you can ask us. Okay, alright, the last learning standard. Of course, after we learn the basic, okay, and how do we apply the information into networks, and the last step or last stage is to solve problems involving networks. Now, example 16. The table shows the choices of public transportation, estimated travelling time, and estimated cost of a journey from Johor Bahru to Kota Bahru. Based on the table, determine the type of transportation that should be chosen for the situation given below. Justify your answer. Okay, so for question A journey involving an adult without time constraint. B, a journey involving an adult with time constraint. A journey involving 2 adults and 2 children. Okay, so if you can find the cost of every transportation, okay, these are the estimated costs. So for A, since that the journey is involving an adult without time constraint, so we can take the cheapest transportation, that is the train. Okay, if you can see the train with bag, even they can take the train with bag. Okay, so the price is still 49 to 55 ringgits. So taking the train, I think that's the best choice. Okay, because of no time constraint, and also that's the cheapest compared to bus and cab. Okay, for B, a journey involving an adult with time constraint. So since that the adult has time constraint, so taking the bus is the best choice. Okay, because the duration is shorter. Okay, if you compare the duration time, using the bus is shorter than using the train. But the cab also gives you 9 hours, but the price is quite high, 120 compared to the bus. So the best choice is the bus for question B. How about question C? 2 adults and 2 children. Okay, since that we have 2 adults and 2 children, of course we may not take the train because of children. They cannot be in the transportation too long. Okay, because in the train we take about 17 hours, even though it is cheap, but not that cheap if compared to cab, because if you count for all the 2 adults and 2 kids, okay, you will get 52. Okay, let's say 52 for me, for without bed. Okay, 52 plus 86. Okay, 14 something. Okay, compared to the cab, only 120. Okay, so for question C, the best choice is taking a cab. Okay, it's more comfortable, and the price even lower than taking the train and the bus. Okay. Okay, this one another example of networks. Okay, this is the flight route. So the map above shows the domestic flight routes of a private airline in Malaysia. Mr. Joshua works in Kuala Lumpur. He wants to visit his family in Kota Kinabalu. State the best route Mr. Joshua can choose. What are the advantages and disadvantages of the choice of flight made? So, if you can see from the map here, from Kuala Lumpur to Kota Kinabalu, there is a direct flight. Okay, so the direct flight from Kuala Lumpur to Kota Kinabalu. Okay, it would be the best choice because it would save time and cost. Okay, this is the advantage of the route. Okay, so the flight from Kuala Lumpur to Kota Kinabalu with transit takes a longer time, and most probably the cost of the journey is also higher. Okay, so that's the best choice for the route. Okay, now that the last self practice to be done from your textbook, page 147, do it in your exercise book, and again please mark your answer after you do, and do correction if there is anything incorrect, or you can ask us if there any problem. So as conclusion, okay, as conclusion, in network graph, in graph theory, we have learned, okay, first, graph with simple graph, and another graph it has loops and multiple edges. Okay, remember this one, and also the terms of degree. And then we learned about undirected graph and directed graph. Okay, after that we learned about weighted and unweighted graph. Then from there we also learn subgraph and tree. Then we use all this basic to solve problems using network. Okay, so that's all for today and for the chapter. So thank you and all the best. Any problem you can contact us, okay, at any time. Again, thank you.